For lesson 7-6, we're going to continue factoring, but this time we're going to look at when our A term, our first coefficient, is no longer a 1. All of 7-5 had us factoring with x squared only. So we're going to combine what we learned in 7-4 of finding the greatest common factor, or the GCF. If we can look for one of those first, sometimes it can make it like we're factoring just an x squared, as we did in 7-5. So when I look at all of these first coefficients, I notice that 3 goes into, or is a factor of, 3, 15, and 18. I also recognize that my x to the third and my x squared and my x, each of those terms has at least one x, or an x to the first. So if I factor out or reduce, pull out the 3x over there, I can think of 3x times what will be left to give me 3x to the third. Well, I already have the 3 out of there, so I don't need that. I just want an x to the 2. Remember, when you have an x to the 1, which we don't write the 1, and an x to the 2, it will make an x to the 3. This is great news because now look, I just have an x squared. We practiced factoring a lot of those in the last lesson. Now, if I take a 3 out of the 15, I'll have a plus 5. X times what makes x squared? Well, I have an x. And I want you to think about that distributive property, where I have my x times x to make x squared. You should always check if you multiplied 3x back in with 5x, you'd get 15x squared. 3 divided out of 18, or negative 18, if you will, is negative 6. And I already took that x out of there, so there's nothing left. I can close it. This right here is a great step. This means you pulled out your greatest common factor. But we want to break it down even more. Our 3x is going to stay out front. We don't ever lose that. But we're going to see if we can break this trinomial down in by factoring to 2 binomials. I like to set up 2 parentheses sometimes to get myself prepared. But let's put our x squared. So I'll take my x squared term here, and I'll put it in that top left box, just like we did in lesson 7-5. And I know that x times x makes x squared. And then if I have my negative 6, I'll put that in the bottom right. So I need to multiply to negative 6. I have 2 terms here, this blank one and this blank one. 2 boxes to fill that must add to 5x. And my choices come from things that multiply to negative 6. Well, what multiplies to 6? 1 times 6, or 2 times 3. I know that I'm going to need a negative in one of these 2 circles, because a negative times a positive is a negative. If I make my 6 positive and my 1 negative, I will have a negative 1x and a positive 6x, which 6x take away an x would make the 5x. So my final factored form will be, I can write either one first. I'll do x plus 6 times x minus 1. Your final answer is here at the very bottom. Don't forget to write that GCF that you first took out. By taking that out, it made it much easier to factor, just like we did in lesson 7-5. Now, before we get a little bit trickier with our a value not being a 1, I want to take you back to a previous problem from section 7-4. Notice we had a 1x squared, so we put that in the top, and we put our c value, the last term, in the negative 6 there. We didn't have to do this because we had the 1 in front of our x squared. But there's a little diamond you can make. And what it would entail is if you took your first term, x squared, times your last term of negative 6, you would get a negative 6x squared. So notice how I've written that at the top. We want to think of times to the top. So if you multiplied or times x squared times negative 6, you'd get negative 6x squared. We put our middle term then, right, the 5x that we've got here, we're going to put that at the bottom. What we were trying to do when we found these factors was think of 2 things, I'll use my orange again, what two things would times or multiply to the top the negative 6x squared, but add to the bottom? That's why we picked a positive 6x and a minus 1x. If I times 6x times negative 1x, I get negative 6x squared. But if I add 6x and a negative 1x, I get 5x. We don't need this diamond so much in the beginning because our x squared was only a 1. But let's look at a trickier example here where our x squared has an a value in front of it, namely a 10. Now, we just finished an example where we could take out a common factor. I see 10, 17, and 3. If I were looking for a greatest common factor, 5 and 2 might work, but 5 and 2 don't go into 17 or 3. These two numbers happen to be prime. So what we're going to do, we know our 10x squared will still go in the first top left box. That's a given. Also, your 3 will go in the bottom box. That's no different. We didn't need this diamond before, but we're going to use it here. Remember how I say times to the top. This 3 is going to multiply by your a, 10x squared. To put that number in the top, we're going to times to the top, all right, times. Now, you might say, well, why do we do this? This just helps you write the math out to be able to organize your thoughts and think about it. Helps you find that pattern a little easier. We want to take 10x squared times 3. That would be 30x squared. Our term in the adding that we want to add to, these two empty boxes need to add to the number in the middle, just like in our easier problems. So I need to think of two things, these two squiggly marks here that I'll put in those boxes that multiply to 30x squared, but add to 17x. Well, let's start with times. What multiplies to 30? 1 times 30, 2 times 15. Oh, wait, right there. What's 2 times 15? Well, I get 30 when I multiply, but 2 plus 15 would be 17. Let's write it. We have a 2x and a 15x. That does multiply to 30x squared, but add 2x plus 15x to 17x. We take these squiggly answers here, and you can put them in either box. I'll put my 2x here and my 15x here. In order to find the factored version, remember, we're looking for those two parentheses, those two binomials that multiply to give us this standard trinomial. We need to do a little guess and check here. We know the outside items must multiply here to 10x squared. So it's generally going to happen that you'll split up your x's because x times x is x squared. I could put a 5x and a 2x to make 10x. Let's talk about why this is the correct spot for it. It does matter this time. 5 has to multiply by something to give me 15. And I can get 5x times 3 to make 15x. Had I put the 2 up here, 2 would not have nicely gone into 15. It would not have been a whole number. We don't want to get decimals. So it was important that I put the 5x above the 10 and the 15 and the 2x across from the 10 and the 2. Because now 5x times 3 is 15x and 2x times what will make 2x? Just a 1. And let's check our last box for fun. What's 3 times 1? 3. Our final factored version is the top of our box, 5x plus 1, and the side of our box, 2x plus 3. Let's try one more here. So if I had my example 3, I'm going to look, do any of these have something in common? 3, negative 2, or negative 8? They do not. So I can't find a greatest common factor. I need to fill in my box with my first term. My 3x squared is going to come from my first ax squared box. My last term is going to be my negative 8. Don't forget the sign with it. Because this has an a value, we want to use that diamond again. So if I make my x, or my diamond, I know that my top term, I want to times to the top. This last term and this first term have to times to the top. So I have 3 times negative 8 is negative 24, and I have my x squared. Now I want to find two things that will also add to this middle term, the negative 2x. That comes from just this middle guy. Middle is always at the bottom. Well, things that multiply to 24. 1 and 24, 2 and 12, 3 and 8, or 6 and 4. I like the 6 and 4 idea because if I put a 6x and a 4x, but one of them has to be negative, these two have to times to the top. Remember, we're timesing to the top. 6 times 4 is 24, but I want it to be a negative, so I have to put a negative in front of one of them. Why would I make my 6 negative? Because negative 6 times, or plus 4, negative 6x plus 4x is negative 2x. I take these squiggly x terms that I find and I fill in either of these boxes. It doesn't matter where you put them, just drop them in. Now we play the game of what multiplies to 3x squared? Well, x times x is x squared. I have a 1 and a 3 to play with. 3 would be a bad choice for the top. Let's talk about why. If I put a 3 here, 3 will not multiply by something to give me 4. So let's switch and put our 3 here. 3 times what makes negative 6x? How about a negative 2? And x times what makes 4x? I have a 4. And check it out. 4 times negative 2 does make negative 8. So my factored form is x minus 2 from the top of my box and 3x plus 4 on the left side. As we said, there can never be enough practice, so let's do just one more. Remember, we're going to put our 2x squared in the top left. Our negative 6, don't forget your negative sign. Now, we're going to make our diamond. I highly recommend you use this diamond because it makes your patterns a lot easier. We take our c value, our constant term, and our x squared term, and we times to the top. So, if I'm times or multiplying these, 2 times negative 6 is negative 12, and I have my x squared. My negative x is the term I want to add to. So we want to think, what two things will I put in these left and the right of the diamond? Both of these left and right are what go in these two empty boxes. What multiplies to 12? Well, 1 times 12, 2 times 6, 3 times 4. If we use a 3 and a 4, they're one number away. That helps be an option because we want a negative 1. So if I put a 4x times a 3x, I get 12x squared. But if I make my 4 negative, negative 4x plus 3x will add to my bottom. Again, it doesn't matter where you put your negative 4x and your 3x back in your rectangle. Just look at your outsides now to try to make the pattern. I've got x times x, which again will always be split up. I could put a 2 in either one of these because 1 times 2 will make 2. It wouldn't be a good idea to put it at the top though because 2 doesn't multiply to 3. It's not a factor. But if I put my 2 here, 2x times x makes 2x squared. 2x times negative 2 makes negative 4x. X times 3 would make 3x. And it just so happens that 3 times negative 2 makes negative 6. So my final factored form would be x minus 2 times 2x plus 3. Try all these triads and examples in your packet. The more practice, the better. And try out that diamond method. Super helpful.